talking about solving radical equations. And a radical equation is an equation that contains a radical expression, which means that under the radicand, so under that radical symbol, you actually have a variable, okay? And to solve a radical equation, the very first thing that you have to do is isolate the radical. And we're kind of used to that because we know to solve linear equations, we want to isolate the variable. To solve absolute value, we wanted to isolate the absolute value. So it's about isolating the equation. So we've got 3 of them here, and it kind of lends itself to friends and lovers because in order to isolate the radical, connected to it by addition is 5, so I'm just going to get rid of 5 by adding its opposite. That gives me the square root of x is 8, and then I want to undo a square root. So to undo a square root, I'm going to square both sides. Because, and if you recall, if I take and square a square root, so let me go parentheses second square root of 5. Okay, if I take the square root of 5 and I square it, watch what happens. It gives me 5. Because radical 5 times radical 5 is radical 25, which is 5. So to undo a square root, you square, and the number just comes out. So the square root of x squared is just x, and then 8 squared is 64. And then it's always a good idea to plug back in and check it. So if I put 64 under the radical 64 is 8 plus 5 is 13, so it checks. Let's take a look at this next one. Think of this as a combo. I have a lover, I have a friend, so I'll get rid of my friend first. That gives me -1 radical x is equal to -3, but now I need to get rid of the -1. So that's radical x is equal to +3. And now that I've isolated my radical, I'm going to square both sides. Radical x squared is x, and 3 squared is 9. For this next one, I'm trying to isolate the radical, and I see connected by multiplication is the 4, connected by addition is the 3. So I get rid of my friend first. That gives me 4 radical x plus 2 is equal to 16. And then to get rid of the 4 that's connected by multiplication, I'm going to multiply by its reciprocal. And now I have the square root of x plus 2 is equal to 4. Now I've isolated my radical. So to undo that, I'm going to square both sides. And that gives me x plus 2 equals, and 4 squared is 16. And then last but not least, I get that x is 14. And again, going back and plugging in to make sure that these answers work is important because we do have extraneous solutions. All 3 of these first ones do work when you plug them back in. Okay? So like on this second one, when I plug 9 in here, the square root of 9 is 3, but 3 times -1 is -3 plus +3 is 0. Or here, if I put 14 in, 14 plus 2 is 16, but the square root of 16 is 4. 4 times 4 is 16 plus 3 is 19, so they check. Okay? Now, if I've got radicals on both sides, okay, I'm going to first make sure they're isolated, and these are, and I'm going to then square both sides. And that actually just leaves me with then 2x minus 1 equals x plus 4. And I'm back to x's on both sides, so I get rid of my smallest. That gives me x minus 1 equals 4. I'm going to then add 1 to both sides, and that gives me that x is 5. Now, always important to check your answers, so let me put in under the radical is the square root of 2 times 5 minus 1 equal to the square root of 5 plus 4. Well, is the square root of 9 equal to the square root of 9? Yes. Okay, so this is a solution. All right, again, remember that when we're solving radical equations, we want to isolate the radical. So in this next one, I have the radical 3x, and then hanging out next to it is plus 10. So I'm going to get rid of the 10 first, and you'll notice then that I get negative 9 is equal to the square root of 3x. Can I take the square root of anything and have it be a negative number? No. This is a no solution. But let's find out what the extraneous is. Let's say that you just kind of went to town and didn't pick up on the fact that it was equal to negative, and you said, okay, now I'm going to square both sides, and that'll leave me 3x, and that's going to give me 81, and then I'm going to get rid of the 3, and that's going to give me that x is 27. Well, when I go back and try to plug that into my original, it doesn't work. So this is what we call an extraneous solution. Okay. All right, let's take a look at this next example. Connected to the radical by addition is 13. And so I'm going to get rid of it by adding negative 13 to both sides. And that gives me the square root of 5n is equal to negative 10. And again, can I take the square root of something and have it equal a negative number? No. So I already know that there's no solution, but if I went to town on it and just kept going, I would have that 5n is equal to 100. So n is 20, but 20 is an extraneous solution. It doesn't work when we plug it back up into the original. All right, there's going to be a section on your test that's going to be asking you to determine if there are any extraneous solutions. So it's going to give you a radical equation. So there's my radical equation. And it wants you to check out these two different solutions to see if they work. So we're just going to plug them in. So the square root of 6 times 5 minus 5, is that equal to 5? Because we're letting x be 5. So is the square root of, and this would be what, 30 minus 5 is 25. Is the square root of 25 equal to 5? Yes. Okay. So we say that x equals 5 is a solution. Now let's try 1. Is the square root of 6 times 1 minus 5 equal to 1? Well, is the square root of 6 take away 5 is 1. Is the square root of 1 equal to 1? Yes. So both of these are solutions. Neither one of them is extraneous. Let's go over here and take a look at this one. We're going to first plug in negative 1. So we have the square root of 12 times negative 1 plus 16. Is that equal to negative 2 times negative 1? Well, negative 12 plus 16 is the square root of 4. And is the square root of 4 equal to 2? Yes. So this one is a solution. Okay? Let's. P is negative 1, and I plugged in for P. Okay? Now we're going to plug in for P and let it be 4. So the square root of 12 times 4 plus 16, is that equal to negative 2 times 4? Well, that's 48 plus 16 is 64. So we have the square root of 64 on this side, and we have negative 8 on this side. Is the square root of 64 equal to negative 8? No. So we say that this is an extraneous solution. Okay. Last but not least, we're just going to plug in and see. This is talking about one of those pendulum swinging things, if you've ever seen them, and the length of the cord right here. And it says that a pendulum has a period of 4 seconds and another one has a period of 2 seconds. And the question means that they want to know is this twice as long as a pendulum with a period of 2 seconds when we're talking about the length? So we're going to plug in and we're going to see. So first off, we're going to let P be 4. So 4 equals 2 pi, and then the square root of L over 32. And we're going to try to solve it for L. But remember that the first thing, anytime I have a radical equation, is I need to isolate my radical. So I need to get rid of the 2 pi. So 2 pi, 2 pi. So that'll leave me with my radical by itself. And on this side, I could go ahead and simplify, and I would have 2 over pi. Okay? So I just multiplied both sides by 1 over 2 pi. But when I have 4 over 2 pi, the 4 and the 2 have a common factor of 2. Now I'm going to undo my square root by squaring. And when I square a square root, then what's underneath the radical just comes out. So I have L over 32. And on this side, 2 over pi times 2 over pi is going to give me 4 over pi squared. Okay? I need to get L alone. So think of this kind of as a lover of 1 over 32. So I'm going to multiply both sides by 32 over 1. And I get L equals, and on the top I have 128. And on the bottom I have pi squared. Now, because pi is irrational, I can't give an exact value for the length, but I could approximate it. So the length, if I put 128 and divide it by pi squared, I get about 12.97. That's an approximation. All right, now let's see if it's 2 seconds. So we're going to go back into this formula, and we're now going to plug in 2 seconds and see if when it's 2 seconds compared to 4 seconds, if it's like double. So let's see. We have a 2 pi square root L over 32. And again, we want to isolate the radical. So the first thing I'm going to do is get rid of that 2 pi. So 1 over 2 pi, 1 over 2 pi. Or those of you that like to divide, it's the same thing. That gives me L over 32. And on this side, I would have 2 over 2 pi, which is just what? 1 over pi? Because the 2's will cancel. All right. Now, I need to isolate my radical. I'm going to undo the radical by squaring both sides. When I square a square root, what I have just comes out. So L over 32. And over here, I'm going to square it. So 1 times 1 is 1, but pi times pi is pi squared. And now, again, think of this as a lever. To get rid of the 1 over 32, I'll multiply by 32 over 1. And that gives me L equals 32 on the top and pi squared on the bottom. Okay. Well, if I approximate that and put 32 divided by pi squared in my calculator, I get 3.24 approximately. So the 2 second compared to the 4 second, it's saying, is it double? Well, if I doubled 3, what would I have? 6. So it's certainly not doubled. It's more like 3 times what gives me 12? 4. Yeah, it's not 2 times, it's 4 times. It's about 4 times as long. That string that causes the pendulum to swing. All right, let's take a look at your homework for tonight. And Yeah, a lot of people were able to get it done in class. Mhm. So let's go through and do a few of these together. Let's start with problem number 6. For problem number 6, it wants us to solve the radical equation. So remember that what we're trying to do is first isolate this radical. Are we missing one? Sorry, you must have been out of your seat. Can you come grab it? All right, so we're going to isolate the radicals. So notice that we really have a -1 in front of the radical and also a 4. So friends go first. So we're going to get rid of the 4. That gives me -10 is equal to, and now I still have a -1 in front. I need to get rid of it. That gives me radical y is equal to 10. And now that I've isolated my radical, I'm going to undo the square root by squaring both sides. And I get y is 100. And then always important to go back and check to see if it works. If I put 100 in here, the square root of 100 is 10 times -1 would be -10, and +4 is -6. So it works. Okay, let's go take a look at number 9. Okay, remember that we're trying to isolate the radical. So in front of the radical, I see the 3. So I'm first going to get rid of it by multiplying by a third. That gives me the square root of x minus 1 is equal to 8. Now I've isolated the radical. So I'm going to undo that square root by squaring. That gives me x minus 1 equals 64. And I end up with x is 65. Again, you always want to check yourself. If I put 65 in here, 65 take off 1 is 64. Square root of 64 is 8 times 3 is 24, so it works. Let's flip to the back side. On the back side for 13 and 14, please note that right here is the radical equation. And this is going to be like something that you're going to see on your test, so I want you to get familiar. And what they're asking is if x equals 1, if x equals 2, if any of those are extraneous solutions. So let's try the 1 first. The square root of 3 times 1 minus 2, does that equal x, which is 1? So the square root of, well, 3 minus 2 is 1. Is the square root of 1 equal to 1? Yeah. Yes. So this works. Okay, now we're going to try the 2. So we plug in, is the square root of 3 times 2 minus 2 equal to x, so equal to 2. So that's 6, take off 2 is 4. Is the square root of 4 equal to 2? Yes. So both of those work. Neither of them is extraneous. Okay. Let's go to 14. In 14, then, you're going to be plugging in the 3. So you're going to be checking 3 plus 6 and seeing if that's equal to 3. And then you're going to come over and plug in the -2. -2 plus 6, is that equal to -2? And if it's not, then you'll say that it's extraneous. Okay? 15. So last week, when we were doing the Pythagorean theorem, I made a really big deal out of the fact that when you take the square root of a variable, so like the square root of a squared, that it's really absolute of a and that you really get two solutions. And I said, but with triangles, we throw out the negative. Well, today we're now looking at the radius of a circle that goes through the point x comma y is given by this equation, okay? So we have circle A, so I'm drawing myself a little circle. This is circle A, and it says that it has a radius of 5 centimeters, so it's telling me what R is 5, and it goes through the point x comma 4. So it's telling me what the y is. The y is 4. So let's plug into this equation. The radius, 5, equals the square root of, and it says x squared. Well, I don't know what x is, so x squared is just going to be x squared, plus y squared. Well, I know what y is. Y is 4. So 4 squared is 16. Now, I've isolated my radical. So I need to undo that square root, so I'm going to undo it by squaring both sides. And that gives me 25 is equal to x squared plus 16. Now I need to get rid of the 16 because we want to isolate the x squared. And that gives me that x squared is equal to 9. Remember that when I take the square root, that symbol means give me the positive root. The positive root of 9 is 3. The positive root of x squared is the absolute value of x. Absolute value means distance of 3. Well, what values of x have a distance of 3? 3 and negative 3. Which means that the points that I can find on this circle, there's 2 of them. One is when it's a positive 3, so 3 comma 4, and the other is when it's a negative 3 comma 4. So I actually have 2 solutions. And those 2 solutions are because when we do an absolute value, there's 2 different answers there. So I did A. You're going to do B by plugging in the things that they're giving you. So they're giving you the radius, 13, equals the square root of, and this time they're giving you what the x is, but you don't know the y. So x squared, so 5 squared is 25, plus y squared. And now you're going to go through and solve it, and you're going to get 2 different values for y. And so for the circle B, you're going to have 2 different values for y. You're going to have 5 comma something and 5 comma something. One's going to be positive, one's going to be a negative. All right.